There is something unusual moving through our solar system, something we were never expecting, something we still don't fully understand. For months, astronomers have been tracking a faint, fast-moving object drifting past our sun, an object so strange that even now, at the peak of global attention, we cannot actually see it anymore. It has slipped behind the glare of the sun, hidden from every telescope on Earth. But before that happened, we watched it very closely. Closely enough to know that this is not just another comet, not just another wandering rock from the cold outer regions of our system. This thing has a name, 3I Atlas, and it has a title. The third confirmed interstellar object ever detected an outsider from beyond our sun's gravitational reach. In just a few months, nearly 100 scientific papers have been published about it. And beyond that, there are countless whispers, simulations, preprints, and observations that never made it into the official catalog. Some of them sound extreme, some of them sound impossible, but all of them are trying to answer the same question. What exactly is 3I Atlas? Is it a normal comet behaving in an abnormal way? Is it a cosmic relic from a star system very different from our own? Or is it something that challenges what we thought we understood about visitors from interstellar space? Today, we cut through the noise. We retrace the story from the beginning, and we uncover everything we truly know about this mysterious traveler called 3I Atlas. Right now, 3I Atlas is passing through the most dramatic moment of its entire journey. It's perihelion, the point where it makes its closest approach to the sun day. For most comets, perihelion is when the real show begins. The heat rises. The ice starts to break apart. The quiet, frozen object suddenly comes alive. But before we talk about what Atlas is doing right now, we need a sense of scale. In astronomy, we don't usually measure distances in kilometers. We use astronomical units, or AU. 1 AU is the average distance between the Earth and the Sunday. So, when we say that Atlas reaches perihelion at 1.4 AU, that means it never actually gets anywhere near the Sun's surface. It passes just inside the orbit of Mars, close enough to heat up, but not close enough for a dramatic plunge. Still, this is the hottest Atlas will ever be. And heat means activity. As the object approaches the sun, solid materials on its surface begin to vaporize instantly. Not melt, vaporize. That process is called sublimation, and it's the reason comets grow a bright halo of gas and dust called a coma. Every tiny particle that bursts off the surface reflects sunlight, giving the comet its glowing appearance. Then the solar wind takes over. These streams of radiation flowing outward from the sun push the lightest particles backward, stretching them into the long, delicate tail we expect to see trailing behind a comet. It's one of the most beautiful phenomena in the solar system, a kind of cosmic choreography between ice and starlight. But ironically, we don't get to witness any of this. Not this time. The sun is blocking our view completely. Atlas is lost in the glare, invisible to every telescope until it emerges again on the other side. Which means that while we wait for its reappearance, we have a rare opportunity to retrace the path it took to get here and uncover the story of where this interstellar visitor actually came from. To understand why 3I Atlas has captured the attention of astronomers around the world, we need to rewind to the moment it was first noticed. On the night of July 1st, 2025, the Atlas Survey, an array of telescopes in Hawaii, Chile, and South Africa, detected a faint moving point of light. At first, there was nothing remarkable about it. The system logs new asteroids all the time, another moving dot, another catalog entry. But then the numbers started to look wrong. Every object bound to the sun moves in a predictable way. The closer you are to the sun, the faster you have to travel to avoid falling inward. Earth moves at 30 kilometers per second. Mercury rockets around at 48 kilometers per second because it's deep inside the gravity well. Even the fastest objects we know, like comets diving straight toward the sun, rarely exceed those speeds by much. But this new object? 58 kilometers per second. And it was still far out, just inside Jupiter's orbit around 4.5 AU from the Sunday. Nothing moves that fast out there. Not unless it's not from here. That's when astronomers realized this wasn't an asteroid. It wasn't a normal comet either. Its speed placed it on a hyperbolic trajectory, a path that curves past the sun and escapes forever. This is the unmistakable signature of something that came from interstellar space, something just passing through. And that is how it earned its name. 3I Atlas, the third interstellar object ever detected. The first was Oumuamua, the cigar-shaped mystery that baffled scientists in 2017. The second was 2I, Borisov, a much more typical comet. But 3I Atlas is different from both of its predecessors in three major ways. First, size. Oumuamua was a few hundred meters long. Borisov was roughly 1 kilometer wide. Atlas may reach 5.6 kilometers across, massive by interstellar standards. Second, speed. It travels nearly twice as fast as the previous two visitors. And third, and most bizarre, its direction. It didn't come from above or below the solar system like the others. It arrived almost perfectly along the ecliptic plane, the same thin disk where all the planets orbit, as if it were aiming for our solar system with uncanny precision. A near-perfect side impact from the vast, three-dimensional emptiness of space. A coincidence? Maybe. But this is where the story starts to get truly strange. If the direction of 3I Atlas feels suspiciously precise, the natural next question is, where did it come from? And to answer that, we have to zoom out far beyond the solar system, far beyond the outer planets, all the way to the structure of the Milky Way itself. When astronomers traced the object's incoming path, they noticed something surprising. Atlas didn't arrive from the quiet outskirts of the galaxy where our solar system lives. It came from the direction of the galactic core, the bright, crowded, turbulent heart of the Milky Way. But direction alone doesn't tell the full story. Space isn't flat. It isn't a two-dimensional map. It's a three-dimensional volume, full of layers and structures that behave differently over billions of years. From above, the Milky Way looks like a classic spiral galaxy, a flat disk of stars swirling around a bright center. But if you flip it to the side, you see something else. A thin, compressed disk in the center, and then a thicker, more diffuse region surrounding it. We call these the thin disk and the thick disk. Most stars, including our sun, belong to the thin disk. But the thick disk is something older, quieter, and far more ancient. Stars here can be 7 to 8 billion years old. And because the region is sparsely populated, objects drifting through it experience fewer collisions, fewer disruptions, fewer catastrophic events. They can wander undisturbed for unimaginable stretches of time. And that is where astronomers believe 3I Atlas originated. Not from a specific star we can point to, but from this broad, ancient territory of the thick disk, an area where cosmic debris can drift for eons without interference. When researchers simulated Atlas's motion backward through time, they traced it through 10 million years of travel. During that entire period, the closest it came to any star was 0.3 light-years, a vast distance of more than 63,000 AU. For perspective, right now, Atlas is just 1.4 AU from the Sunday. In other words, it has been wandering alone for ages, untouched, undisturbed. A relic from a part of the galaxy we may never truly understand. If everything about 3I Atlas already seemed unusual, its speed, its mass, its direction, then the next set of discoveries pushed the object from interesting into deeply strange. Because once astronomers began observing Atlas on its approach toward the sun, the data started to show one anomaly after another. The first red flag came from TESS, NASA's exoplanet hunting satellite. TESS wasn't even looking for comets. But in May 2025, it happened to be scanning the region of space where Atlas was passing through the orbit of Jupiter. This gave scientists a rare month-long timeline to measure the object's brightness. The expectation was simple. As Atlas moved 1 AU closer to the Sun, its brightness or flux should increase by a factor of about 1.5. Instead, it increased by 5. That meant Atlas wasn't just reflecting sunlight, it was rapidly shedding material, forming a coma far earlier and far more violently than any normal comet should at that distance. And when scientists analyzed the coma, they found something even stranger. It was dominated by carbon dioxide. Most comets in our solar system contain far more water ice than CO2. But Atlas was inverted. Roughly 8 parts CO2 for every 1 part water. That's the opposite of what we're used to seeing. And it explains why its coma formed so early. CO2 sublimates at much lower temperatures. But the surprises didn't stop there. When researchers measured how sunlight scattered off that cloud of gas and dust, they expected the usual pattern: positive polarization, the same signature seen in almost every asteroid, comet, and interstellar visitor ever studied. Instead, Atlas showed strong negative polarization, the most extreme ever recorded for any object in the solar system. That alone would have been enough to raise eyebrows. But then came the metals. Early in the summer, astronomers detected nickel in the coma, nickel atoms being dragged out from the surface by the escaping gas. But strangely, they found no iron. Nickel and iron are born together inside dying stars. They're cosmic twins. Wherever you find one, you almost always find the other. So where was the iron? Weeks later, as Atlas moved closer to Mars, iron suddenly appeared, and the nickel-to-iron ratio shifted towards something more typical. This suggested that the comet was changing rapidly, its layers peeling back, revealing different chemical signatures as sunlight carved into its surface. And then came the final twist. The tail. When Atlas first formed a tail, it was pointing the wrong direction toward the Sun, not away from it. This only happens when the solar wind is too weak to push back the early coma, causing material to pool on the warm side of the object. Only later, as the solar wind strengthened, did Atlas develop the normal, fan-shaped tail stretching away from the Sunday. Each of these anomalies on its own would be remarkable. Together, they paint a picture of an object unlike anything we've ever seen, a comet revealing its secrets layer by layer, behaving in ways that challenge every assumption we have about interstellar visitors. While Atlas was slipping behind the Sun from our point of view, it made a remarkably close pass by another world, Mars. On October 3rd, the object came within 0.19 AU of the red planet, the closest approach it would make to any planet in the solar system. And unlike Earth, Mars had a front row seat. From the surface of Jezero crater, NASA's Perseverance rover captured long exposure images of Atlas streaking across the night sky. The pictures aren't sharp. The rover was never designed to photograph faint objects moving at extreme speeds, but they confirmed what models had predicted. The coma was bright, the object was active, and Atlas was shedding massive amounts of material. Meanwhile, high above Mars, the European Space Agency's ExoMars orbiter recorded a clearer image. Even so, the resolution wasn't high enough to distinguish the nucleus from the coma. For that, astronomers hoped for a shot from NASA's Mars Reconnaissance Orbiter, home to the most powerful telescope in Mars orbit. Whether such an image was taken or when it might be released remains uncertain. For now, we wait. Atlas will emerge from behind the Sun in early December, giving us our first chance to see what the intense heat of perihelion has done to it. And on December 19th, it reaches its closest point to Earth, still a distant 1 AU, but close enough for the world's best observatories to capture fresh data. Then comes the epilogue. On March 16th, 2026, Atlas will pass 0.36 AU from Jupiter, offering the Juno probe one final opportunity to photograph the interstellar traveler before it fades back into the darkness of deep space. What will Atlas look like after its encounter with the Sun? What layers will have peeled away? And how many new questions will replace the ones we thought we had answered? Soon, we'll find out. But one thing is already clear. Objects like 3I Atlas remind us how little we truly understand and how vast the universe still is.